Okay, so I did catalytic converters. So this is a technology that was created to better our air quality. So the main issue that was looking to be resolved with this invention was air pollution. So why was it created specifically? In 1963, the Clean Air Act was passed. This was targeting a lot of different industries. But as time progressed, we realized that the auto industry was one of the biggest culprits in air pollution. So a 1965 amendment was passed regarding vehicle emissions specifically. So this was called the National Emissions Standards Act. And at this point in time, the auto industries were really scrambling to find something to limit harmful emissions in order to comply with this. Um, the catalytic converter was invented by a French mechanical engineer. His name was Eugene Houdry, and he was quite ahead of his time. He had a passion for race cars. He had actually even developed a more efficient type of fuel for race cars. He was really an environmental activist. He was concerned with air pollution um, and also in vehicle efficiency. So his invention focused on both of those things, improving vehicles' fuel efficiency and also improving the amount of emissions coming from said vehicles. Now, again, this happened in, we're talking in 1963, 1965. He had prototypes of this invention going on around this time, but the actual catalytic converter that we see in use today was not created until 1973, nor was it put in vehicles as a standard until 1975, when it was perfected. And the reason for this was all of these vehicles were using leaded fuel. And for lack of a better term, the leaded fuel was making the catalyst go kaput before it could do its job. So when I say Eugene Houdry was really ahead of his time, he absolutely was. So until unleaded fuel became something that we could use widespread, the catalytic converter wasn't able to be put to work. So, what is it? It is literally a catalyst. And what this catalyst does is it converts hydrocarbon, right here, which is your unburnt fuel, carbon monoxide, which is your partially burnt fuel and engine oil, and then nitrogen oxide and nitrogen oxide. These are there are multiple different oxides of nitrogen being produced during the chemical reaction. So these oxides are what's being produced at the highest heat point during combustion during the reaction. And what the reaction is doing is turning these hydrocarbons, carbon monoxide, oxides of nitrogen, into water, carbon dioxide, and nitrogen, respectively. And these chemicals are things that are found naturally in our atmosphere. So these are the chemicals being input. This is what's being output. And this is much better to have in our environment, in our atmosphere, as opposed to this. So there are various types of catalytic converters. Typically, they're going to be either a 2 or a 3-way converter. This is just like a physical format. And this is going to be solely dependent on whether or not the vehicle is gasoline or diesel powered. And then within the catalytic converter, they're typically made out of stainless steel. They have a stainless steel body, but within the catalyst itself, which I will show you shortly, there is platinum, palladium, and rhodium. And these are 3 rare earth metals that need to be mined, that in combination with a couple of other materials create the reaction needed to turn these into these. So how does it work? We have an input pipe, so right here, that's where your harmful emissions are coming in. Then we have our catalyst chamber, which is everything that's going on in here. And we have our output pipe, which is where the less harmful emissions are coming out of. So within the catalyst chamber, we have this catalyst cushion mat. And the cushion mat is really just keeping everything in here stable. It's keeping it from wiggling around, and it's also protecting from thermal expansion because we don't want it to explode. Then we have our heat shield, so that's this layer here, and what that's doing is protecting the body of the converter from getting too hot and then therefore causing damage to the undercarriage of the car. And then we have this oxygen sensor port. So that's going to be right here on this model, we can see. And that actually plugs into your car. So our modern cars are a lot more electrical than you may think. Even our purely gasoline powered cars, they have a motherboard in them. And the oxygen sensor port, that's what plugs into this O2 port here. And what it does is it monitors the amount of oxygen being input just to make sure that it is at a safe level to keep things running efficiently. And what determines if this is a safe level or not is programmed into the car, and it's calibrated. When your car performs system updates, it's based on EPA standards. So the Environmental Protection Agency is coming up with what is the correct level of oxygen. This is updated to your car, and that information is transmitted through this to make sure all of this is running smoothly. So here's just a better view for you of a breakdown of the catalytic converter, how this piece of technology works. So this is where we have the exhaust gases. This is the hydrogen, the hydrocarbons, carbon monoxide, nitrogen oxide, all this that's coming in. Again, stainless steel body. It's a better view of the oxygen port. Your heat shield, which is this layer underneath. And then here's your thermal protection mat. Within this, we have the actual catalyst. So it's a type of honeycomb structure. And then here we have some of the chemicals that I was just talking about with the stabilizers, which are these metals, the platinum, palladium, and rhodium. So all of this that you see here, all these types of chemicals and metals are what are converting this stuff into this stuff. This is just a little depiction of the actual reaction. So within these little honeycombs, we have these chemicals, these metals reacting with this, creating this. So it's gonna go through here, go through the process within the catalyst, pass through the oxidation catalyst, which is going to focus specifically on the hydrocarbons, because we don't want carbon monoxide, we want carbon dioxide. And that's about it. It's not a super complex design. But these metals here are going to create a little bit of an issue for the catalytic converter, which would be that they are prone to theft. Those metals are very valuable, and a lot of people, in many areas, it's very common to have the catalytic converter literally cut from the vehicle for this reason. But I am going to talk a little bit about the pros and the cons of catalytic converters. The pros are really good pros. They are reducing harmful emissions significantly. It's much better for the environment. All the cars, trucks, any vehicles today have this. It is mandated. Well, any vehicle today should have this, not to say people do not cut them off of their own cars for reasons I will discuss. They do improve fuel economy. That was part of Hudri's concern was to make a car that performs at peak efficiency. And then performing at that peak efficiency is actually improving the longevity of the car, particularly with the newer ones that have this oxygen sensor port and are able to monitor how efficiently it's running. It is definitely going to be better for your car to be functioning with that in most aspects. However, the delay in the output of exhaust actually does create more back pressure in the engine. Some back pressure is normal and needed, but the converter does put it's a small amount, but it does put an amount of back pressure on the engine that gives you less engine power. So your vehicle is going to be at peak performance in just about everything except for horsepower. So this is something that, people who are deeply rooted into the car community or racing community are not going to love about catalytic converters. So that's where you're going to hear about people just taking it off. And then we are limited to unleaded fuel, which is really not the biggest deal. We did all switch over to unleaded fuel entirely by 1996. However, this does create there's not a lot of differentiation in what types of fuel we can be using now because of this. So this brings us to kind of an issue with using up what resources we do have. It can only be this type. And then also we have to mine for platinum, palladium, and rhodium. These can create really environmental issues in themselves. So, it's a question of whether or not it is outweighing the good that this is doing for the environment by reducing the emissions. And then again, they are prone to theft. So that is not, that's something that we're seeing more recently, but definitely not a pro. And then some political and economic repercussions. So these are mandated due to the EPA standards. Not everybody likes mandates. They're typically not very well received by the public, as we have all seen recently with COVID. So there's always going to be a percentage of the population who has some disdain for this. And then because of this mandate, it can be seen as related to a political agenda. Typically, it's associated with the more left side of politics. And this does create a little bit of animosity between the two parties, which is always going to be there. But this is just part of the fight for the environment that we see a lot of pushback on. They're expensive to manufacture. Again, we have to mine for these things, and it's not, I don't want to say complex per se, but an intricate catalyst to be putting together that has to go on every car and truck manufactured for daily use. So it's a lot. And then again, in many areas, this is a cause for theft. So there are definitely going to be some issues there and some pushback because of that. And here are my sources. So yeah, that's about it. The catalytic converter is really an amazing piece of technology. Eugene Houdry really understood the inner workings of mechanics and cars and fuel efficiency and chemistry in order to be able to put that together. So